folks, I am here to talk about DHCPv6, and as I've written here, it's the same in concept as v4 in that you can allocate information from a server to a DHCP client, only it's different. There are more options and more ways to configure it. So what will we explore in this session? So first thing, with DHCPv4 there were no options in terms of what was a configuration of a client. You basically said IPv6 address DHCP and you were done. With v6 we have some additional flags that we can set, and we'll explore what they are. This is because there's a mechanism called SLAC, which is a stateless order configuration, or a stateless address order configuration mechanism that comes built in with v6. We'll just do a quick review of SLAC to show how it allocates address, then we'll configure stateless and show you that adding some more options that you can distribute to attached DHCP clients. So we'll also look at using the stateless server and talk about these flags more specifically. In your reading either on NetAcad or the CCNA book, you should have read about the M, the managed flag, and O, the other flag. When you set a DHCP client with the O flag, that says it's ready to participate in stateless configuration from DHCP. The managed configuration says it's going to be working with stateful. Now, why do we even bother with these types of things? Well, built into v6, this SLAC mechanism gives you the basics of what you need for a device to auto-configure itself when it attaches to a router, get a prefix, generate its IPv6 address in EUI format, which is covered in the v6 recording separately, and you're off and running. You've got connectivity, you can get basic communication going. What stateless operation offers you over and above that is a way to centralize domain information and DNS server information that then gets distributed everywhere you have clients of that DHCP server. So if you could imagine, the way one would normally configure a DNS server is via manual command on the router, but if you can centralize that and you happen to grow your list of servers, it's just a very easy job to add that one additional address in one server rather than go into all your routers and add an extra server command into them. So stateless DHCP is useful in that perspective. Stateful addresses, stateful DHCPv6 adds one additional piece of functionality. What that does is allows you to define the address that actually gets assigned to the interface. With SLAC and stateless operation, the address assigned to the client is derived directly from the prefix of the attached router interface. With DHCPv6 stateful operation, you can define the pool of addresses that the host will use, and that's if you really want to control things in a fine-grained way throughout the enterprise or network, that is the way to do it with DHCPv6. There is a slight gotcha. We'll look at that particularly when we see the assignment of default router address to a PC. Often we think of things in the terms of the global unicast address, but it's actually the link local address that gets assigned to the PC. We'll look at configuration for DHCPv6 relay. That's quite straightforward. Very similar to what we have with DHCPv4. It's just a single command that's put in the same location as you would put the helper address command in DHCPv4. Just in v6, it's IPv6 DHCP relay destination command that you use. I will talk about the configuration for stateful DHCPv6. In fact, it's extremely similar to stateless configuration. There are only two changes. The two changes are that you add an address command in the pool to define the address range that you want to have addresses assigned from, and you change the flag. You also change the clients to make sure that they are using DHCP rather than auto configuration. Unfortunately, Packet Tracer does not support DHCPv6 stateful. The commands simply aren't there, so we'll have to just accept it as it is for the video here and execute the commands in the lab on real devices. We'll also talk about the client configurations and summarize with some useful show commands. So with that, we'll take a quick break and turn straight over to the lab. Okay, so here we go. This is our simple topology for exploring DHCPv6. 3 routers, a single PC. We're going to spend most of the configuration time here on router 2, which I've called the right router. There's the right router, the central router, and the left router. That makes it easy for me to remember. So, the first thing we're going to have to do, as with all things V6 related, is turn on unicast routing. We have done that. Let's just do a show run to see that we haven't got anything more V6 in here that could be disturbing us. No, it's all pretty much easy configuration. Let's have a look at PC0. Here I have PC0 with no configuration other than its automatically generated link local address. Remember, we can always see that by the FFFE here in the middle of the host portion, using just the link local prefix and then creating the host address from its MAC address. So that's all good. Now then, the first thing we're going to do is go into go into the router 2, the right router here, and configure an IPv6 address on the interface that connects to PC0, and that is gigabit 01. So we're going to go interface gigabit 01 and then do an IPv6 address, make it something simple with a 64-bit mask, as we always do with V6, and that's all we've done. We just turn on V6 and given an address. So let's go and look at PC0, change it from static configuration to auto configuration. There we have it. It has, through Slack, taken its address for global unicast of 2001:1 and generated the host portion itself. It's also taken the link local address of the right router MAC address, concatenated that with FE80, the link local address, and has got a link local address for an IPv6 gateway. So pretty much we're good. We're operational here. Now, if we want to go a little bit further and populate this area here, the IPv6 DNS server, let's go back to static information, clear that out, and show how we set up stateful DHCPv6. Okay, so with stateful DHCPv6, the first thing we're going to do is do an IPv6 DHCP pool with a pool name, and let's look at the things we could set here. Let's just set the DNS server because that will marry up with what we were able to see on the PC. So DNS, and we have to put in a v6 address for it, 2010:1:1. Okay, that's great. We have set up a stateless DHCPv6 pool. Now then, remember we talked about having these flags. So we have to set a flag in the interface that's going to be offering up this information to tell the client that you can get your address from Slack, but I've got other things for you, other options of information that you should get from me. So interface gigabit 01, we say IPv6, neighbor discovery, other config flag. That's great. So that's set up the other config flag. And remember, other is always connected with stateless DHCP operation. There's one further piece of information we have to put in here, and that is to bind that pool of addresses to clients on this interface. Remember, in DHCPv4 it was the IP address that made that connection, but that's not the case. With IPv6 you can have multiple v6 addresses on the interface, and you have to bind the pool specifically to the interface here. So we do that with this following command: IPv6 DHCP server pool, and there we are. That's what we have done. That's all we need to do. We have set up the pool, we have set up our option flag, and we've set up our binding between the interface and the client. So with a bit of luck, I click on auto config here, and lo and behold, we get the DNS server address DHCP pool. That's all well and good. Okay, let's have a look at the DHCP relay command. Okay, so in this configuration here, I've got gig 00 on the right router going to the central router. So let's do interface gig 00 and just give it IPv6 address 2001:2:1/64, and then let's go to router 1 and say that interface G00 has IPv6 address 2001:2:2/64, and let's just make sure I can do a ping. Oh, I addressed it incorrectly, didn't I? What a silly boy. Okay, that's what we're looking for. Alright, so that link is operational. If we go to gigabit 01 on that device, and give it an address on 2001:1/64 network, what I can do is configure the DHCP relay command. So on my right router here, let's do a show IPv6 interface brief. What I want is basically to tell this interface here, which is the gigabit 01 interface on my central router, that the address over here on the gig 0 is the one that I want to use as my destination for DHCPv6 requests. So let's do that. Got to go to the gig 0. Okay, here I'm on the central router. On the interface gig 01 over here, I'm going to give it the destination address on the right router here. Okay, to have the DHCPv6 relay working, this is the command. Unfortunately, Packet Tracer does not accept it, but it is the correct command. We can again try this out in the lab on real devices. If I try to hit enter here, you'll just see that it's not something that the Packet Tracer is going to accept, but that is the correct iOS command. The next thing I wanted to look at was maybe just a little bit of stateful server operation here. So as I mentioned, there's two things that you change. The first thing is to go into the IPv6 DHCP pool _1. Now here you'll see we've got very limited options. The one that should be there in a real device is address. Then this allows you to define the prefix and various timers associated with the allocation of the address in that command. Unfortunately, as I said, we haven't got support, so we'll just have to defer that till class. The second thing supported, if we say interface G00, you say IPv6 neighbor discovery, and we change it to a managed flag. So if we do a show run now, we've got the managed config flag and the gigabit 00. Just want to show you one other thing. Interface G0/1 IPv6 neighbor discovery managed. Do show run, and you'll see that you're actually setting both of them, which is a bad thing. I don't know of times when you want to do both. What you should do to make this work properly is to issue the no command, the no IPv6 neighbor discovery other config, and just leave it at the managed config when you want to use stateful operation. Okay, that's the main things to look at here. So the show commands that you might find useful. So you can do a show IPv6 DHCP pool. That tells you what information is available and being distributed from that pool. You see it's got the DNS server address that we configured it with. You can do a show IPv6 DHCP interface, and that tells you you've got 01 in server mode using pool 1, and we've got this thing at the bottom, rapid commit disabled. What that does is just an optimization in the way the messages flow between the client and the server. It's not a requirement, but if you have a device that is configured only for rapid commit, you can enable it in this configuration as well. We've got show IPv6 interface. Gives you a nice bit of information here. It shows you what address has been assigned to it, tells you what type of configuration the hosts are using, stateless auto configuration, and where you've joined multicast addresses, the standard ones. Now, some other things we can look at is the show IPv6 DHCP bindings, and that's telling us we don't have any other routers bound to that address or that interface. Okay, that is about it for as far as we can go with Packet Tracer. I will be getting access to full devices and being able to do a much better job of recording. First things to review regarding what we've just been through on Packet Tracer. With V6, you've got to notice that there are 3 options for assigning addresses. Slack, which is the built-in V6 one, that gives you the address and default router distribution. There's stateless operation that you configure with the option config or other config flag option, and what that will do is allow you to distribute, in addition to address and default router, you can distribute DNS and domain information. And then the whole enchilada is the managed config flag, and that's stateful operation where you add in the address that you want to assign to the client, so you are not tied to taking the address from the attached router to the client. We noticed that when you do get a default router assigned to a client, the address that it uses for that is link local. Just be cautious of that if you're going to do any access link configuration. And we did review stateful configuration, even though we won't be able to do it in Packet Tracer. I will be doing a video for that once I get access to some real devices. To do that, to stateful configuration, the only real difference from stateless configuration is to add the manage flag instead of the other config flag or the other config option flag, and to put in the address prefix into the pool. With DHCPv6, one of the key things that you must not forget is that, or you must remember rather, is that you must remember to put in the binding between the pool and the interface. There's no automatic connection between the two as there is in DHCPv4. There's plenty of useful show commands. Here's a few that you should get familiar with. One I did not show is just show IPv6 host or show host, and that's a cool one that will show you when you've got domain or DNS information distributed. IPv6 helper for DHCP, very similar concept. You direct broadcast addresses to a named unicast address, but instead of the helper address command, you use the DHCP relay destination command. And that is about it. Let's close off here and see you in class.